Next on my list, in the case that I have a combination of sines and cosines in the integrand's position, neither of which is being raised to an odd power, I will dive in and reduce the order of these factors. The way I do that is I use my reduction of order identities from trigonometry. Recall. Of course, these are derived directly from your double angle identities. So notice how in both these cases I can reduce the order of sine of x or cosine of x by using this reduction angle identity, or these reduction angle identities plural. And so let me dive in and show you how I can possibly accomplish a task of dividing this integral using these reduction angle identities. So here I go. I merely rewrote the first factor. Now take a peek at sine squared of x and the cosine squared of x. I will reduce the order with those two factors. Next, allow me to clean up. I will expand that binomial square. I will expand. I will combine my terms. So in anti-differentiating term by term, piece of cake, angle reduction identity, shave off one factor of the cosine of 2x, make another u sub, or in this case, z sub. Here I go. Let me go ahead and commit to this first. I just used my angle reduction identity for the cosine, excuse me, my goodness. Let me say that one more time. Using my reduction angle identity for the cosine squared of 2x. And if you don't mind, I'm going to separate this out for this one, as I suggested with the first video on these trigonometric intervals. I will shave off one factor. Convert the remaining two to sines using my first Pythagorean identity. So it looks to me like with the first integral, I'm ready to anti-differentiate term by term. Now let's see, I have to confess, everybody, when I split this up with two integrals, I did forget to distribute that factor of 1/8. Then my apologies, but there it is. Now for this one, if I can just come in and let, say, z be equal to sine of 2x, then certainly dz is this. Now committing that substitution, I can now rewrite the second integral as such. Now I'm back substituting. So I'm just taking a quick peek to see if there are any like terms I can combine in here. So let's see, how about the sine of 2x? So I have this many of these from the first grouping, this many from this grouping. They completely cancel each other out. Next on my list, that term. And lastly, this is the only term I have not yet considered. Now, I know I've erased a lot, but remember what the initial substitution was. You and I dove in and simply converted things with our reduction angle identities. So I guess technically speaking, that substitution doesn't need to be taken care of in terms of back substituting. I was simply using identities to rewrite what I had in the integrand's position. And I just think there's nothing left that I can do to clean this up further.